Hello, good people. Welcome to video one of topic 3.3, which is finding derivatives of inverse functions. We're going to talk about three different methods that you can find derivatives of inverse functions. And then the goal is for you to kind of figure out which one to use depending on the situation you're given. But before we do that, I wanted to talk about just quickly review what an inverse function means, right? So, for example, I could have a function f of x, which I would call x to the third power, right? And the function f of x equals x to the third power means for every input I have, this function performs an operation and I'm going to get an output on the other side. So if my input is 1, I'm going to substitute 1 in here and I get 1. Sorry. Or if I substitute 2, this function is going to take us over here and it's going to give us 8, right? Or if I take 3, this function is going to take us to the output and the output's going to be 27. So this is what the function does. Great. But the inverse function says we start with the original outputs and we take them back to where they came from. And so if I start at 1 and I go back, well, I'm going to end up at 1. Or if I start at 8 and I go back, I'm going to end up at 2. And if I start at 27 and I go back, I'm going to end up at 3. So the inverse function is the undoer, if you will, right? It reverses the process of the original function. Now, in our example, we have a very explicit, specific inverse function that undoes a cube. And that function would be the cube root. And so sometimes it's possible to find the inverse function. And once we find the inverse function, then I guess what I need you to remember is my inputs and outputs switch roles, right? So for example, there's a point in this function that is 327, right? When my input is 3, my y, my output is 27. But on the inverse function, the point is 27 comma 3 because they switch roles, because we reversed the process. And so my output became my input became my output. So that's kind of the big conceptual idea. So let's go back. So our goal is to find derivatives of inverse functions. And so method number 1 says, hey, if you can find the inverse function, then find the inverse function, take the derivative, and then evaluate it at the point that you're being asked to evaluate it. So that's what we're going to do here in this first video. So I am given a function. The function is f of x equals x cubed minus 1. But I know that g is the inverse function. And I know that because this symbol says f inverse is equal to g. So g of x is my inverse function of f. We want to find the derivative of g, which is the derivative of the f inverse function, at 7. But this is a function that I can actually find the inverse equation for. So what we're going to do is we're going to do that. And if you remember back in Algebra 2, and a little bit in Pre-Cal, but Algebra 2 for sure, we said we can find the inverse function by reversing and interchanging the x and the y variables and then solving for y. So I'll remind you that whenever I see an f of x, this whole thing is y. And so the first thing I'm going to do is I'm going to switch my x and my y. So instead of y, I'm going to say x equals, and instead of x, I'm going to say y to the third minus 1. Everything else stayed the same, except my equal stayed the same, my minus 1 stayed the same. But wherever I saw my x and y, I interchanged them. And now we're going to solve for y. So I'm going to add 1 on both sides. And then to undo the cube, we're going to take the cube root of both sides. And this is my inverse function. This is, if you'll allow me here, f inverse of x, also known as g of x. Right? I created the inverse function by using that process, and I found the derivative. Well, if this is the derivative, then I can take the derivative of g by just taking the derivative of this thing. But the derivative of this function, I have an inside-outside situation, so I got to find the derivative of the outside with the inside still in it, times the derivative of the inside. Well, the derivative of x is just 1, and the derivative of 1 is just 0, so 1 plus 0, that's just 1. So this is my derivative. Awesome. Can I make it look a little bit nicer? Probably. Let's do that. So this is really 1 over 3 times the cube root of x plus 1 quantity squared. Remember that negative exponent means I can take a reciprocal, and then the fractional exponent means I'm taking the cube root and I'm squaring whatever's inside of the cube root. This is the derivative. This is the derivative equation. Hey, we're looking for the derivative at x equals 7. But we're looking for the derivative at 7, so then I'm going to substitute 7, and that's going to be the end of my story. Okay, so g prime of 7 is 1 over 3 times the cube root of 7 plus 1 squared. And I could do 1 over 3 times the cube root. 7 plus 1 is 8, and 8 squared is 64. And the cube root of 64, what number times itself gives you 64? I believe that's 4. So therefore, my derivative value is 1/12. So this is a little laborious, right? Like I had to do like multiple steps. I had to actually find the inverse function, which we did right here, take the derivative of the inverse function, which we did here, and then substitute the value given in order to get to my final answer. Multiple steps, but I'll get to it, right? I got to the answer. Okay,